To find the product of these two lines, we can solve it a couple ways. One way is to just pick any x value. So I'll pick x equals 0. So this first line, when x is 0, y is 2. And then this other line, when x is 0, y is negative 4. So product means to multiply. So 2 times negative 4 means the product at x equals 0 is negative 8. Okay, pick another point. When x equals 1, the first line y is 3, second line y is negative 3. 3 times negative 3 means the output is negative 9. Okay, next point, x equals 2. First line y is 4, next line y is negative 2. 4 times negative 2 is negative 8. Okay, so we can also easily do the intercepts. When this line is 0, it doesn't matter what the other line is. Anything times 0 is 0. Similarly over here, if the top line is 0, 0 times anything is still 0. Okay, so this gives me a pretty good idea of what the graph looks like. So looks like it matches choice A. Okay, which quadratic function has the narrowest graph? So the larger the absolute value of A means it's a narrower graph. Okay, so I'm looking for which of the choices has the largest absolute value of A. This absolute value is 3, 2, 1/11, 1/5. So 3 is the largest absolute value, right? Because negative 3x squared and 3x squared will have the same width, just one will open upward and one will open downward. So that's why the negative sign doesn't affect narrow or wide. I just care about the absolute value. Okay, find the axis of symmetry and vertex. So axis of symmetry formula, x equals negative b over 2a. So for this quadratic, a is 4 and b is 5. So let's plug those in. Okay, negative 5/8. And since this is multiple choice, we should eliminate the answers that are already ruled out. So A and B are out because they don't have the correct axis of symmetry. Okay, so now for the vertex, well, the axis of symmetry always lies, the vertex always lies on it. Like for this graph, if this is the axis of symmetry, we see the vertex has to be on it. So this is also the x coordinate of the vertex. Okay, so both of our remaining choices already said that, so we do need to find the y coordinate. Okay, so remember the use of an equation is it tells us for any x, how do we calculate y? So I need to substitute this x that I care about into this equation. Okay, so instead of x squared, it becomes negative 5/8 squared. Instead of 5x, it becomes 5 times negative 5/8 minus 1. Okay, so remember when we square fractions, both parts get squared separately, and a negative squared, negative times itself is positive. Oops. Okay. Okay, so I just got everything to have a common denominator of 16. And now simplifying, this is negative 25 minus another 16 is negative 41 over 16. And in mixed number form, that's negative 2 and 9/16. So that means the correct choice was D. Okay, so which graph is correct? And label axis of symmetry and vertex. So axis of symmetry, x equals negative b over 2a. In this case, a is 1, it's invisible 1, b is negative 4. So negative b becomes negative negative 4 over 2 times a is 1. So 4 over 2. Axis of symmetry, x equals 2. So I can get rid of this choice. And I also need the vertex. So I've already got the x-coordinate of the vertex because the vertex is always on the axis of symmetry, but now I need the y-coordinate. So I'll plug this x-coordinate into the function. So f of 2 is 2 squared minus 4 times 2 plus 1. 4 minus 8 plus 1, negative 4 plus 1 is negative 3. So vertex of 2, negative 3 is choice C. Okay, height of a ball is modeled by this function. In how many seconds does it reach the maximum height? And what is that maximum height? Okay, so first thing I notice is that A is negative 16. So I know that whenever A is negative, that means the parabola opens downward. And that's important because if I care about the maximum height, that will occur at the vertex. Okay, so the vertex, of course, has an x and a y coordinate. The x in this case is the time, so this will answer the first question. So I'll figure that out by doing negative b over 2a, although I suppose in this case it's actually t, not x, as our variable. Okay, so b is 40, so negative b becomes negative 40. 2a, a is negative 16, so 2 times negative 16 is negative 32. Okay, negative divided by negative is positive. Okay, the the t coordinate of the function, its vertex is 1.25, so it can't be d. And now I need the actual height, so I'm going to plug this value into the height equation. Okay, so it looks like choice C. Okay, g of x plus k of x. So one thing I like to do is to sort of match up the like terms. So I'll write g of x like normal. And then I'll write h of x underneath each matching like term. Okay, so k of x has 2x squared minus x minus 9. And then now I can just go down each column. So 5x squared, 2x minus x, still have 1x left over. Negative 1 minus another 9 means now minus 10. Okay, 7, find f of x times g of x. So f of x is 3x minus 2. And I'm going to multiply g of x, which is 3x squared plus 2x minus 1. Okay, so in this case, it's actually possible to factor g of x a little bit. So how do we get 3x squared? That's 3x times x. Okay, then I'm trying to get a negative 1, so what multiplies to negative 1? Positive 1 and negative 1. But I notice my middle term is positive, so I want a bigger positive than a negative. So that means I need to multiply 3 by the positive and the smaller 1x by the negative. Okay, and you can always distribute back out to check. 3x squared plus 3x minus x is now 2x minus 1. Okay, so we see that this is choice A. Okay, find f of x times j of x. So here I need to make sure to distribute 12x squared plus 24x minus 8x minus 16, combine the two middle terms. Looks like choice A. Okay. So remember, vertex form is ax minus h squared plus k. So if we compare what the starting function I'm going to write in vertex form, So we started with a is 1, x is not minus anything, so it's x minus 0 squared plus 0. And then we turned it into negative 1 x plus 2 squared, and still plus 0 because it's not there. Okay, so k did not change at all, so that means it didn't move up or down, so I can get rid of these two choices right away. So I only need to know, did it translate left or right? Okay, so in the original function, x squared, h is 0. Okay, and then in the new function, h is negative 2. Okay, you have to remember that because the vertex form has a minus already, when it's a plus 2, that means you subtracted negative 2. So if h went from 0 to negative 2, h decreased. So decreasing is to the left. Okay, so I'm going to write this in, vertex form. So the general formula looks like this. So matching this to this, so a, there's no coefficient, so it's an invisible 1. X is not minus anything, so it's really minus 0. And k, there's no plus anything on the outside, so it's also plus 0. So at the moment, h is 0 and k is 0. Okay, but we're going to move it 3 units up. So vertical translation is controlled by k. And then 2 units right. Okay. So right means that h is getting larger. So I need to add 2. So h is now 2. Okay, so back to vertex form. So a is still the same. Okay, so now we have x minus h, so x minus 2, and then plus k. So that looks like choice B. Okay, convert to vertex form and identify the vertex. I'm going to do this on scratch paper. Okay, so vertex form, again, looks like this, where hk is the vertex. So to find the vertex, I can use the axis of symmetry formula, negative b over 2a. In this case, b is 4, a is an invisible 1. So negative b is negative 4, 2 times a is 2 times 1. Okay, so the x-coordinate of the vertex is negative 2. So I can eliminate choice A. And now I need the y-coordinate of the vertex. So I just plug this x value into the equation. So x squared becomes negative 2 squared, plus 4 times x is 4 times negative 2, minus 7, 4 minus 8 minus 7, negative 4 minus 7 is negative 11. Okay, so negative 2, negative 11. Okay, solve. So remember, solve what value of x makes this true. So when the 0 is by itself, I can always try to factor first. So what gets x squared has to be x times x. And then I'm trying to get two numbers that multiply to equal 6 and add up to equal 7. So plus 1 plus 6 works. X squared plus 6x plus another x is 7x plus 6 at the end. Okay, so now using the zero product property. Okay, so if this blob equals 0, doesn't matter what this is, because 0 times anything equals 0. Or this blob could equal 0 instead, because if this is 0, no matter what this is, anything times 0 is also 0. Okay, so x could equal negative 1, or x could equal negative 6. Okay, problem 13, solve for x. So I'm going to try to factor first. To get 2x squared, that's 2x times x. And then now I need two numbers that multiply to equal negative 15. Okay, so it's probably not negative 15 and 1 because those are far apart and that would lead to a b term far from 0. So it'll probably be 3 and 5, but I don't know if it's positive 3, negative 5, or the other way, or I don't know which one goes where. Okay, so I want the b term to be barely positive, so they've got to be pretty close. So I probably don't want to put the 5 here because that would make this a 10, which is really big. So I think the 3 should go here, which makes the 5 go here. And then again, I want the positives to win. So 2x times 3 would be 6x, which is more than 5x. So I've got to make this positive and this negative. So again, check 2x squared plus 6x minus 5x is now plus x minus 15. Okay, then I separately set each set of parentheses equal to 0. And solve each. Okay, so x could be negative 3 or 5/2. Okay, solve for x. Okay, so you could distribute this out. Just remember, you don't just square each term, you actually need to write it out twice. But the strategy I'll use is to square root both sides. Okay, so that cancels out the squared, leaving what was on the inside. But just remember here, like the quadratic formula, because we're asking what number squared equals 25, it could either be positive 5 or negative 5, because a negative times a negative is a positive. So moving this over. Okay, so it could either be negative 4 plus 5, which is 1, or negative 4 minus 5, which is negative 9. So that would be choice B. Okay, so even though now the variable is z's, it's exactly the same as if it's x's. Okay, so I can try to factor, but taking advantage of the fact that this is multiple choice, I see radicals everywhere. So that means I probably can't factor into integers. So I'm just going to skip to the quadratic formula. So remember, the quadratic formula works for all quadratics. So if you're ever uncertain, you can always use this. It just usually takes a little longer than factoring whenever factoring is possible. Okay, so A is invisible 1. B is 16, C is 44, so let's plug all those in. Okay, so square root of 80. 80 is not a perfect square, but there's a perfect square hidden inside of it. So I'll copy the rest of it down first. So radical 80 can be split up into radical 16 times radical 5, which means that I can take the square root of 16 outside. Square root of 16 is 4. Okay, and then now when I divide by this 2, because these are separate terms, the plus sign separates, or sorry, the plus minus sign separates them. This means both parts of it get divided by 2. Okay, so negative 8 plus 2 radical 5, or negative 8 minus 2 radical 5. So that looks like choice D. Okay, question 16. X squared minus 4x plus 20 equals 0. So I can try to factor, but I don't think it's going to work. So I'm going to use the quadratic formula now. Okay, so A is an invisible 1, B is negative 4, C is 20. Okay, so negative b, negative 4 is now positive 4. b squared is negative 4 squared minus 4 times a times c all over 2 times a. So simplifying this, okay, so square root of negative 64. So this will not be a real number, but we see in the answer choices we are allowed to use imaginary numbers. So remember that negative 64, so let me copy the rest of it first. Negative 64 is really radical negative 1 times radical 64. Okay, so square root of negative 1 is defined to be I. And then square root of regular 64 is 8. Okay, so because these are separated by plus and minus, that means these are separate terms. So when I divide, both of them get affected. So over here, 4 divided by 2 is 2, and 8i divided by 2 is 4i. So it could be 2 plus 4i or 2 minus 4i. Okay. So to solve this, looking at my answer choices, I can see that it looks like it's going to be a complex number for sure, so I'm not going to bother trying to factor. I'm just going to jump into the quadratic formula. Okay, so for this problem, A is invisible 1, B is also invisible 1, and C is positive 4. So plugging in all those values. Okay, so square root of a negative number is going to lead to a non-real answer, but we see that we are allowed to use non-real answers. So remember that we can split up a radical into a product of radicals. Okay, so negative 15 is 15 times negative 1. Sorry, I should keep the denominator. Okay, so radical 15 we can't really do anything with, but square root of negative 1 is defined to be I. Okay, so negative 1 plus or minus I radical 15 all over 2. Okay, so it looks like choice B. Okay, use the discriminant to determine how many roots this has. Okay, so even though the variable is not x, it's still the same variable both times, so we can use the discriminant just like as if it were x's. Okay, so A is invisible 1, B is 3, C is negative 4. Okay, so what is the discriminant? Well, we don't need to do the whole quadratic formula. You could, but this question doesn't ask for the actual roots, it just asks how many. So if we think about how or why we sometimes get different answers, it all has to do with this radical. When this part inside the radical is a whole number, I can either add or subtract it, meaning I get two real answers. Okay, but when this equals 0, it doesn't matter if I add or subtract 0. So that's why I can only get one answer sometimes. Or if this becomes a negative number, square root of a negative number becomes imaginary, and then I can either add or subtract imaginary numbers, so that gives me two complex roots. So let's see what the discriminant is for this problem. B squared is 3 squared, minus 4 times A is 1, times C is negative 4. 9, and then let's see, negative 4 times 1 is negative 4, times another negative 4 is now positive 16. Okay, so the discriminant is positive. So again, that means that when I square root a positive, I'll get a positive answer, meaning I'm allowed to both add and subtract it, giving me two real roots.